Thank you. Can everybody hear me like this? Is it good? Okay. So I got asked about 2 weeks ago by Stilos to give this presentation, and I was thinking a bit, I could give you the standard company presentation, but I thought maybe it's more interesting to sort of see how this process went, like how I graduated from architecture about 3.5 years ago on this SALT project, and I thought maybe it's interesting to tell you a bit how this process went to go from a graduation project to a company to a second company. And to now having a team of 10 people working full-time. So 2 projects I'll talk about, the SALT project, which was the result of the architectural engineering studio, and Concrete, which started about 2 years ago. Both have to do with materials and production technologies. But maybe to sort of go back a bit, before I started my graduation, I think it was 2014 at the architecture faculty, I had the chance to work in China for a while. So I was an architect there for about a year, working for a Dutch company, and sort of going around the country, doing sort of business development, speaking to clients, and sort of looking at new projects. So in sort of that regard, I came more on the sort of edge of cities in China, which were developing. And you sort of see the impact that construction has on the landscape, on the environment, on the incredible amount of material that are displaced just in order to make something. And that gave me, at least in my graduation year, the sort of desire, a will to make something that had to do with using local materials, sustainable materials, and trying to make an architecture with less impact than what is traditional. So that became the SALT project, which has, of course, to do with salt. And salt is a really interesting material. It used to be a very precious material. This is how they used to harvest salt in sort of salt evaporation ponds and in big mines. And it was very sort of valuable. The word salary comes from salt. There's a lot of trade routes based on just the harvesting, transporting, and selling of salt. And even still in sort of hard to reach areas in Timbuktu. And this is how salt is made today. And what's interesting when you look at this material through climate change, modern production technologies, it's gone from a sort of very, very valuable, expensive material to a material that's cheaper than sand and is in many ways even a waste material. So, one example of how salt can be a waste material is in Israel, in the Dead Sea, where there's different kinds of salt. They harvest, for example, lithium and potassium salts and sodium salts. So kitchen salt is not harvested, it's just dumped in the desert. It's millions of tons that are just sort of thrown away. It's too expensive to transport it, they just dump it. This is another area in France where they also harvest salt. Here they harvest salt for the roads. It's been sort of traditional harvesting ponds for 2,000 years. The Romans used to harvest salt here, and through that a kind of ecosystem started where you get birds eating little shrimp from the salt evaporation ponds and kind of stuff. And now you see that because the demand for salt is so low. Winters are getting warmer, there's less salt needed for the roads. These people who work in these fields are out of a job. The animals that live in these fields they're sort of getting rid of the fields, so the animals don't have their ecosystem anymore. And this is in the Persian Gulf, which is actually the main issue, where through a large-scale desalination, so making fresh water out of seawater, and sort of pumping back the salt into the ocean, you see that actual salt levels are rising. So from 3.5% to 4.5%. When you get that, you get huge amounts of ecosystem problems. You get fish dying, plants dying, they can't survive in this high salinity environment. And when you're talking about sort of the amount of materials, is millions of tons. It's an insane amount. So in sort of this graduation project, I came to this problem, sort of found it out through a lot of research of looking at local materials that are, in this case, a desert/sea environment. I thought, well, maybe it's interesting to sort of explore this material and see what you can actually do with it. So one sort of obvious example what you can do with salt is crystallizing it. So you can sort of have a saturated solution, boil out the water or evaporate the water, and then you're left with salt. And this salt can grow on all kinds of surfaces. So it can grow on a piece of string or on a plate, or in this case on a bowl. You can melt salt about 820 degrees. You get a sort of ceramic material. If you mix it with clays, you get an even harder ceramic material, which is something we've been doing quite a lot as well. And what I was interested in mostly, so this is another way of crystallizing salt, in this case on a dress, so it works as a kind of fabric stiffener. And what I was interested in mostly is finding a way to turn this kind of powdery crystals into something that was strong and could potentially support a ceiling, for example, and just sort of explore where this would go. And at the time, my tutor was like, I'm not sure where this is going to go. Well, let's just see. Let's find out. If it goes bad, we'll have to switch to something else, but let's see how it goes. So we basically started just in the kitchen mixing salt with a bunch of different polymers, starch, for example. And actually quite soon, through just sort of trial and error, we were able to make reasonably strong blocks. So I went to civil engineering, to chemical engineering, to talk to professors about it, see what do you guys think, what's the strength, what can we do to make it stronger. And this is something I noticed during graduation, that actually at the TU Delft there's so much knowledge available that can help you sort of take solutions a bit further and go a bit deeper into the science. That helps a lot. People are very open to this kind of stuff. So with that help, I was able to make a material that was relatively strong, like a low strength concrete, it's like 20 MPa compressive strength. So good in compressive strength, weak in tensile strength, so good for making arches and domes and these kinds of shapes. So we're even able to make SEM photographs. And then so the graduation thesis was about seeing, well, what if we have a kind of system where seawater goes in, you use separate it into salt water and fresh water using solar power, use the fresh water to grow crops, give people to drink, and use the salt to make a kind of architecture, kind of speculative project. What if we develop this material a bunch further and use it to make architecture? So based on the properties of the material they had at the time, you could make some kind of design. So based on the properties, the production process. And in this case, the graduation thesis was a production facility for a salt building. It looked a bit like this. So you have mainly a cast salt structure with sort of very intricate patterns inside and sort of compressed salt blocks as floors and more rigid rectangular shapes. So just big sort of arched domes. And here you see how it would be produced. So almost different ways of producing, using different technologies to produce salt components into this factory. So I graduated on this project in 3.5 years ago, so 2015. And during graduation, I put it in a few competitions, and then sort of a couple weeks after graduation, I actually found out that I won 2 of them. So it was really quite cool. So I had a kind of rough material and some money to sort of, I have some time and some money to explore what to do with it, like how to bring this a bit further. So I opened up a small studio. I didn't have enough money to make a building, so I thought, well, maybe start with some furniture. And then why not make a kind of a piece of furniture that would allow you to test different recipes, so different sort of ways of making this material, so using different combinations of salt and starch and other binders, as well as fibers to reinforce this material. So I made this design for a kind of chair. I sort of had a small production facility, so I made a mold for this chair, where you would then cast in the salt. I made on the top right, you see this big wooden box. That was my salt oven, so it's a kind of super DIY box in which you could dry out the salt long enough, at a temperature about 65 degrees. Then after about a week, you would have this kind of salt chair. And it actually worked, so here you have a kind of a huge mess and a salt thing in the oven. First try is a bit scary to release this mold, but it actually worked really well. So we're able to get a strong material, very heavy kind of chair-shaped object. I think it weighs about 80 kilos, but it's strong enough to hold me at least. And so this sort of went into a few exhibitions like Dutch Design Week, Prague, Salone del Mobile, the Architecture Biennale, and a bunch of different places. And that got me in touch with the people of a big art foundation in the south of France. So they had this issue, or we have a lot of salt, or we don't know what to do with it. Can we try out some stuff to make products out of this salt and see if it's so much we want to use it, let's see what we can do. So we organized a workshop in these kind of huge salt fields. Let's see if we can play this video. No. Anyway, so you get these fields the size of Paris, 50 square kilometers. Incredible sort of white, pink, blue colors in this thing. Huge amounts of salt. And we had a workshop there with tools like a printer, ceramic oven, a press, all kinds of tools to make objects out of this salt. Incredible amounts of it. So we started playing with this oven, with a printer, and we made some kind of rough, not very good, because we only had about a week, but products out of this salt. So ways to make it in a way waterproof using ceramic binders, ways to 3D print the salt using a powder printer. So it was kind of a start to make products out of this thing. So we had a small exhibition. And this kind of led to two projects in a way. The first is the making of tiles. So by mixing salt with a ceramic binder, baking it, it's close to the melting point of it, you get a very interesting process where with only 1 or 2% of clay, you can make a material that's almost waterproof, not completely, but almost. And you get these sort of fascinating pink, orange shades, as well as very good mechanical properties. So you get really ceramic tiles. So you see with different types of clay, you get different colors. And what's really cool about salt, that if you shine a light behind it, the white grains are actually transparent or translucent, so you can see the light through it. So this is an ongoing project right now. We have some tiles in production, and we're in talks with a few people to make projects out of it. And the second thing we did was 3D printing the salt. So we had a powder printer. I'll show you more later. And a simple recipe to print a very fragile, delicate salt structure. So we made a mixture specifically designed for 3D printing. And with that, we were able to do, for example, this. It's a lamp. And here you see how this transparency of the salt allows you to sort of create very sort of intricate, see-through objects. So I think this lamp went to a few exhibitions as well, and also to the Salone in Milan. It's not in production because the salt ruins the printer, it just rusts everything, which is not great. But it's a nice way of sort of exploring this 3D printing process. And basically from that came a kind of spin-off company, which is called Concrete. Because we were exploring this salt material in the printer we had, and the reason we went for this printing, because it started off with this sort of big chair kind of shapes, and you sort of realize when you make a shape that is slightly complex, that has some curves and kind of stuff, it's very difficult just to make it. It's just so much effort to make a mold. So for example, for this shape, it's a polyester mold. So first you make a design in Rhino in this case. You make basically a duplicate of that. You use that to send to a robot where you mill a shape in EPS. You smooth it out, you put polyester over it, and that you smooth out again, and then you cast your salt in it. So it's a very long process. It takes weeks to make this mold. It cost me a lot of money also. So we're kind of looking for a way to make making easier in many ways, and 3D printing can be a nice solution for that. So we had this kind of old printer that we first tweaked to make salt components. Then this should be a video, but it doesn't work. But anyway, how this printer works, I think there's one here at the model lab as well. It's a tool that basically puts down a thin layer of powder, and then with an inkjet print head, you print sort of the section of your model on this powder. There's a reaction between the ink and your powder, and that sort of how builds up your model. So it's a continuous layering of thin layers of powder and ink. So at the end of the process, you have a box of powder, you vacuum out the powder that you didn't use, and you have your object remaining. So we were playing a bit with this. So we started off playing with salt, and then we went also to more cementitious concrete-like materials to get a strong material, which would probably be way more interesting. And so we ended up with a material called geopolymers. And it's kind of technical story now, but when you have basically a range of powders that have cementitious properties that are not cement. So in this case, metakaolins, fly ash, GGBS, all waste materials from the coal and metal industry. When you activate them with a chemical, you get a material that looks like concrete. It's a slightly different chemical reaction to concrete. It doesn't matter so much, but what's important that you basically use waste materials, you use a lot less CO2, but the properties are quite similar to concrete itself. So geopolymers, there's a lot of research on this in civil engineering, and we thought, well, is there a way to make this kind of very sustainable material and make it suitable for 3D printing with the knowledge that we gained in the sort of process before? Turned out to be incredibly complex. So we made something that was kind of working. We weren't able to get the printer working for this kind of stuff. It was a huge mess to sort of get the right ink through the printer, and at a certain point we realized, like, if you actually want to do this stuff, and what we had in a way was quite cool. We were able to make a material that was very cheap and sort of very detailed materials and stronger than was on the market. So in a way that was quite good. But to get it to a commercial level, and this was a process that took about a year to sort of talk to a lot of people, figuring out, okay, what is the market demand, what is the pricing for this kind of stuff. It took a long time to understand, okay, if we really want to take this seriously and make a company or a project out of it, we have to build our own printer. It's a very complex relationship between the type of powder you put in, the ink you put in, and the sort of tool you use to make these kind of shapes. So yeah, basically that's what we did. It took a long time. We basically started off with just a very rough idea and maybe 5,000 euros of some funding that we got through a clean tech accelerator. Said, okay, we like the idea, here's some money to support you. We used that to sort of validate this whole business proposition. So, like, how is it possible to sell even cementitious 3D printed concrete-like materials? And we used sort of the results of this validation to raise a bunch of money to support this company. And with that, we ended up being able to print, to sort of make, first of all, to print this material and to build the printers for this job. So what we have now is basically a tool, two types of printers. Basically a tool that allows you to print extremely cheap, very strong materials and the precision of 100 micron. And the thing about this thing is you can sort of print any shape that you want. So this is the printer in our office. And so maybe a nice example of what this actually means. So this is the city of Palmyra in Syria. It was destroyed by IS or ISIS in 2013, and then the Russians bombed it. So we joined a Harvard project that was sort of looking at these ruins and sort of mapping them in 3D using photos and old drawings. And they sort of rebuilt it in a kind of 3D model, just in Rhino. And then, so we printed a part of the arch of Palmyra. So I think this kind of image shows how intricate you can make shapes. So this is really the only way to make a kind of stone-like material. The only other way is just give a guy a hammer and a chisel and a block of stone and sort of let him work for about 2 weeks. And this we printed in 4 hours, and it cost us 60 cents. So then this becomes quite interesting also for a larger scale and for a bunch of different applications. That can be restoration, it can also be architecture, more parametric design, which was in our case our interest, or things like molds and other types of components. And especially when you get this material price down so much, it's interesting to sort of look at a larger scale application. So with a relatively small investment, you're able to build fairly large scale printers that print, any kind of shape. So if you basically look at it, if you have a sort of cubic meter of materials, you can sort of think of any shape within this cubic meter, and it would cost you around €1,000. So that's incredibly cheap. And so that's a bit the sort of the dream of it. So we have an investor, we have a team of 10 people, and we're building these and engineering these machines at the moment. So also that is a kind of ongoing process. And then for us, how we would ultimately like to see it, is when you have in your design process, you'd have a small printer to prototype things, you'd have a large printer to sort of go directly to the building site. So direct link between your design process and your production process. So that's basically where we are as a company right now. So we're at the RDM in Rotterdam, building machines and sort of making salt tiles. So for me, to summarize what I sort of learned in my architecture short career, is that in general, this is what I'm interested in. This is how I see, in this case, the future of making, the future of architecture. So using kind of alternative local materials, locally sourced, looking at, in a way, technological production processes. And my last slide is a bit about kind of discussion, question. So I'm, in a way, an architect, but I don't really work as an architect. So what is the future business model of the architect? Is it this, the typical model where an architecture gets a job from a client and he bills 80 hours or 500 hours and then gets sort of price per hour? Or is the future of the architect someone who is in control of the production process? Maybe the future architect owns a factory. And so I think there's a lot of examples of sort of people taking this role of becoming both an architect and a creator. Like Studio Rap is doing it, Pieter Stoutjesdijk is doing it, Jelle Vieringa is doing it. So there's a bunch of people doing stuff, and I think that's quite interesting. So in general, that's what I would have to say. A short story about at least my process from graduating till having a company. And that's it. Happy to hear comments.